Okay, today we are going to learn the linear programming by graphical and simplex method. So first of all, we'll look at the maximization problem. Okay, we have a small factory produce two type of toys. Okay, which they got car and diggers. Let me write down this. Okay, you can put out like this. Let's say C stand for car, D stand for digger, and then cars and diggers. In the manufacturing process, two machines are used, which is the molder, colorizer. One digger needs 2 hours on molders and 1 hour on colorizer. Here from this statement. A bit faster. The molder and a digger need 2 hours on the molder and 1 hour on the colorizer. A car needs 1 hour on the molder and 1 hour on the colorizer. 1 hour molder, 1 hour colorizer. The molder can be operated for 16 hours. So mean it's less than or equal to 16 hours a day, and the colorizer 9 hours. So less than or equal to 9 hours. Each digger give a profit of the profit digger is 16, car is 14. So from the information we extract to table, mean a car need 1 hour molder, 1 hour of colorizer. A digger need 2 hours of molders and 1 hour of colorizer. Molder constraint, we have a maximum 16 hour. Colorizer maximum can be operated 9 hours. One car can give a profit of 14 pound and one digger can give a profit of 16 pound. We would like to maximize the profits. So we want to maximize the profit. Let the variable C stand for number of car produced. Let the D stand for number of diggers produced. Then Z stand for profit. So this will become the problem maximize Z. Each car can give 14 pound of profits. Each digger 16 pound of profits. So it will produce C cars. So C times 14. So that's why it's 14C. One car 14 pound. One digger 16 pound. It will produce D number of diggers. So D times 16, or this is 16D. Subject to the constraint, we got molder constraint. 1 day maximum can operate 16 hours. So C is number of cars produced. So C times 1. D is number of diggers produced. So C times 1 plus D times 2 will be less than or equal to 16. So you got C plus 2D less than or equal to 16. So for colorizer constraint, so C times 1 plus D times 1 less than or equal to 9. So this is what we call the linear programming problem, where the C, D must be greater than 0, because number of cars cannot be negative. It can minimum 0, but cannot negative. So this linear programming problem, and this is a maximization problem, and this is so-called standard maximization problem because inequality here for maximization problem must be all less than and equal. So first of all, we are going to show you how to solve it using graphical approach. So mean you can first of all sketch the graph of linear graph C plus 2D equal to 16 and then C plus D equal to 9. Okay. So here, the purple graph here, this is actually C plus D equal to 9. So you got C plus D equal to 9, right? To get to plot this linear graph, first of all, when you let C equal to 0, D will be equal to 9. Okay, this is plot D versus C. So when C is so your coordinate will be DC 9 0. Okay. D is 9 here. So this point is 9 0. Okay, later on when you let D equal to 0, C will be equal to 9. So we got 0 9. Okay, D0, C equal to 9. Yeah. So this is the 0 9. Okay. And then for C plus D less than or equal to 9 is actually or below the graph. The region will be below, including this one. Okay. Later on we got 2D plus C equal to 16. So 2D plus C equal to 16. Okay, when you let C equal to 0, D will be 8. So your point is actually 8 0. Yeah, this point 8 0. Okay, when D equal to 0, C equal to 16. So you got 0 16. Yeah. But here actually the graph, this graph is actually plotted using Excel. Okay, let's say this is 16. So this is 0 16. Okay. And then the region 2D plus C equal to 16 is also below. Hence this region not include. So the feasible region, feasible solution region is actually you got the area below the blue line overlap with the area below the purple line should be only this one. Okay, this one not include. Okay, okay, no, so this area, this one not include. Only this part. The overlap of the area below the blue curve and the purple curve. Hence you got one corner. Normally the corner point you got 0 0. This is C. This is D. Sorry, this case D C. D and C. Yeah. So if you and your Z is actually what's the Z just now? 14C plus 16D. Okay, Z 14C plus 16D. So when C0, D0, your Z is 0. Okay, we got the first corner point is here, 0 0. So and then we traverse anti-clockwise. Okay, the feasible solution region up to here. This part not include because you want the overlapped region below the purple curve and the blue curve. This part not include. Okay, oh, okay, and show first. Okay, mean it's actually this region not include. Okay, and then so you have 0 0, and then the next point is 8 0. D is 8. C is 0. You calculate it, you get 1 2x. You may use your scientific calculator to help you quickly calculate it. Yeah. Okay, you can put in 14c plus 16d. You calculate. So c is that's not this point. C is 0, sorry. This is C is 0, D is 8. So you get 1 to 8 here. Yeah. C0, C0, D8, we get 1 to 8. So another corner point, this point, how we get 7 to, you have to solve these two equations simultaneously. So you have 2D plus C equal to 16, D plus C equal to 9. Okay, let's say this is equation 1, this is equation 2. You take equation 2, deduct equation 1, 2D minus D, you have D. C minus C, no more. 16 minus 9, you have 7. And then, okay, plug in D is 7, so C will be 2. So that's why you get, okay, this point, okay, D is 7, C is 2. 7, 2. 7, 2. Then you plug in into the calculator just now. Calculate again. C now 2. Okay, D is 7. So you get 140. 140. So we traverse, it will start from 0, 0, of course 0. Okay, the first corner point, 8, 0, you get the answer. The profit is 128. 7, 2, the profit is 140. Then you still have one more point. Okay, this point is C is 0. Sorry, D is 0. D is 0, C is 9. Okay, then you calculate again. Okay, this is C is 9, D is 0. So you get 126. 126. So from 1 to 8, okay, from 0, 1 to 8, 140, 126, the maximum is 140 happens at, okay, C, mean number of car you need to produce is 2. Number of digger that you need to produce is 7. Okay, this is using graphical approach. This is using graphical approach. Okay, and then graphical approach limited to 2 decision variable, C and D. When you got, okay, you want to decide how many car, how many digger that you need to produce. So this type of variable is what we call decision variables. You can only have 2 decision variable. If you got 3 decision variable, then okay, the solution will be in 3D space, will be a little bit, okay, difficult to view. Then if you have more, okay, let's say 4 variables, we cannot view, okay, the feasible solution region at all, 4 dimension. That's why we have another technique, which is simplex method. Okay, so for simplex method, first of all, we are going to put the information into a table. Okay, me no, this is what we already put out into the table. Okay, so we have the linear programming, maximize z equal to 16d plus 14c subject to the constraint 2d plus c. Okay, all right, subject to 2d plus c less than or equal to 16. Okay, the second constraint, d plus c less than or equal to 9, where c and d must be greater and equal to 0. Okay, the graphical approach, we got limitation. Okay, this we limited to, okay, it's limit to 2 decision variables only. Okay, that's why we are going to use a simplex method. Okay, to use simplex method, okay, actually what we need to do is actually this one will maximize when we maximize, okay, z minus, we bring all the decision variable to left hand side, 16d minus 14c equal to 0. Okay, subject to the inequality will be, okay, chained to equality by add up one slack variable. So 2d plus c plus s1 equal to 16. Because initially this one is, okay, left side not equal to right hand side because less than. So they are, okay, mean, okay, the weightage at left hand side is lower. So we add up one slack variable so that they can be equal. So similarly for the second constraint, d plus c, we add up another slack variable s2 equal to 9, where the c, d, s1, s2, okay, must be positive. So, okay, we are going to transform this into Microsoft Excel. Okay. Okay, the problem. Okay, this is a LP problem. I change to the we change to the simplex. Okay, simplex, we will have z minus 16 d minus 14 c equal to 0, and then subject to 2d plus c plus s1 equal to 16. Okay, and then d plus c plus s2 equal to 9. Okay, where the d, c, s1, s2, okay, greater and equal to 0. Okay, d, c, okay, are called decision variable. S1, S2 called slack variable. Okay, then we transform, okay, put it into the table. Okay, initial table we denote as a, okay, we denote as a table 0. Then we got, okay, create the column basics for the basic variable. Okay, what's meaning of basic variable? Contains, okay, only one non-zero entry. And then non-basics, okay, contains, okay, all value. Okay, so we have create, okay, a basic variable column. Later on the z, okay, is our profit z column. Okay, you have a d, and then you have c. You got the s1, s2. Sorry, where is my s1? S1 here. Yeah, how much it? Okay, okay. Okay, where S1 go? Other way. No. S. Okay. Okay, S1, S2. Okay, the right hand side and then the ratio. So you put the information, okay? Start from objective function. Z is 1, D is negative 16, C is negative 14, S1 0, S2 0, right hand side 0. Okay, like this. Okay, the first constraint 2D plus C. So Z 0. So 2D plus C. Okay, plus S1. Don't have S2 0. Right hand side 16. Okay, and then the second constraint, you don't have Z. D is 1, C is 1, S1 is 0, S2 is 1. Okay, right hand side is 9. Okay. So this is a initial table. So after that, you need some concept, okay, for maximization problem. Okay, for maximization problem, identify, okay, you identify the most negative column. Column from objective function row. Where is it? Okay, so for maximization problem, you identify the most okay, maximization problem, identify the most negative column from objective function. So it's a negative 16. It's the most negative. Okay, so this will be pivot column. In pivot column, okay, is the most negative column. Okay, later on you calculate ratio. Ratio is the right hand side divided by pivot column. So calculate ratio, start from constraint. So divide by pivot column. Okay, copy it down. Okay, and then pivot row. Okay, is actually come from the smallest ratio row. Okay, so the smallest positive ratio. So the smallest positive ratio. Okay, the smallest positive ratio give the pivot row. Yeah. I mean, this row is pivot row. Okay, and then you identify pivot cell. Okay, is the intersection of pivot column and pivot row. Pivot column and pivot row. Okay, so will be 2 here. So you identify until you get the pivot cell. Okay, and then basic variable, as we said, contain only one non-zero entry. So Z is pivot. Z is basics at row 1 here. Okay, so you put Z here. S1 is basic at second row. So this is S1. S2 is basic at the last row. So this is S2. Okay, so for initial table, D, C are non-basic variable. So you see non-basic variable contain, okay, each entry contain value. So these are non-basic variable. Okay, and then for basic variable, the initially, okay, we'll let Z equal to 0 happen when S1 equal to 16, S2 equal to 9. Okay, after you identify the pivot cell, you can copy it down, Control C, and then Control V to paste it. Okay, change it to table 1. Okay, after you find the pivot cell, okay, you must make, okay, pivot cell, okay, become, okay, pivot cell become 1 unit. Okay, using suitable row operation. Must make pivot cell become, okay, 1 unit using suitable row operation. Okay, so I will indicate, let me make everything a bit smaller, column. Okay, then I insert, should call, no, sorry. Yeah. Okay, initially, let's say I label this as a R1, okay, R2, R3. So table, okay, in table 1, this will be R1 prime. This is R2 prime. This is R3 prime. So, okay, first of all, we are going to make changes on R2 prime using the row operation. Is actually takes from the previous R2, divide everything by 2. Divide the whole row 2 in table 0 by 2. Okay, so I'm going to do is I select, okay, make sure you select the whole row 2 in the new table. Okay, from Z until right hand side, don't include ratio. And type equal. Okay, and then select the old row 2, divide by 2. Control Shift Enter. So you can see. Mean 0 divided by 2 is 0, 2 divided by 2 is 1, 1 divided by 2 0.5, 1 divided by 2 0.5, 0 divided by 2 0, 16 divided by 2 8. Okay, this is the first one, the first technique. If you cannot select, okay, you may key in one cell. Let's say here, the new row 2 equal to the old row 2 divide by 2. Okay, and then you point to the right bottom of the cell. You see the little plus, you may drag it to copy. This is shortcut to copy. Okay, if you still cannot drag, don't know how to drag, okay, then what you need to do, Control C, and then go to the new cell, Control V, Control V, Control V, Control V, Control V, one by one. Okay, of course, I will prefer the first one. Select the old row 2, divide by 2, Control Shift Enter, faster. Okay, this is a row indicator. This one so row indicator. Okay, I want to make the format cell. Alignment, I want wrap tag. Okay, row indicator. This is the so row operation. Okay. So after we take the old row 2 divide by 2, we get this new, okay, row 2. Okay, so first step, make pivot cell become 1 unit. We are complete. Okay, this one you may delete the, okay, only this is our pivot cell. I just make the pivot cell become 1 unit, 1 unit and highlight with red color. Okay, after you make the pivot cell become 0, then you have to make, okay, cells below and on top of pivot cell become 0. Okay, so mean you have to make this cell 0, this cell 0. Okay, using suitable row operation. Using suitable row operation. Okay, for example, I want to make the new row 3 here become 0. I want to make it become 0. Okay, the row operation formula that you are going to make changes on, let's say you are going to make changes on, let's say row, I put it row I, in row I, then you will have plus minus, because I cannot key in uh, so you have the formula plus minus k time of new pivot row, and then you put into the I prime. Okay, you take the row I, you can plus minus k time on new pivot row, and then you put the changes into the new row I. Okay, for example, I want to make changes on row 3. Okay, I will take row 3. Okay, I see row 3 is 1. So mean 1 time of row 3 minus 1 time of R2 prime, I will get the cell below pivot cell becomes 0. So R3, the operation is R3 minus R2 prime, like this. Okay, so I select a new R3, type it equal, take the old R3 minus the new R2, Control Shift Enter. So it's like 1, mean this row minus, you take this row, not included ratio, means 0 divided by 0. 1 divided by this one, of course you get 0. Okay, all row 3, 1 minus 0.5 get 0.5, 0 minus 0.5 negative 0.5, 1 minus 0 is 1, 9 minus 8 is 1. Okay, and then to make this cell become 0, so the operation we see, this is row 1, so you must take from all row 1, so you got negative 16, that's why I plus 16, that's why the operation is row I plus minus. If negative 16, you plus 16. Okay, but don't put R1 plus 16. You must multiply with how many times of your new pivot row. So new pivot row is a R2 prime. Okay, so this one must be the old row 1 plus 16 times of the new pivot row. Then Control Shift Enter. And then the process, table 1. So we have to repeat this process, make pivot cell become 1 unit, make cell below and on top of pivot cell become 0 using suitable row operations until there's no more negative column. Okay, since we still have a negative column, okay, so this is this will be column C now will become pivot column. So after when we pivot at column D, you will notice D will become basic variable. So you go in, become basic variable. So S1 leaving. So S1 is what we call leaving variable. S1 leaving. Okay, and then now D become basics. D become basic variable. D go in as a basic variable. Okay, and then since column C still contain negative value, so column C is a pivot column. So repeat finding the ratio, which is the right hand side, here G17, divide by pivot column. Okay, copy down the ratio formula. Okay, the smallest ratio now, positive ratio is 2. So mean now the last row will become pivot row. Okay, this is pivot row. Okay, and then intersection of pivot column and pivot row give you pivot cell. Okay, so then you can copy it here, Control C. Okay, now make sure you paste value, just paste value. Okay, because if you copy, all the value run because of the relative row operation in Excel. Okay, so we don't want this. Okay. Okay, now undo. Okay, never mind. I just want to delete. Okay, delete everything. I don't want. Okay, Control C. Okay, and then you can paste value. Paste value. So now this become table 2. Table 2. Table 2. Okay, and the yellow color fill in, you can remove it. Okay, so now this is now the new pivot is at the new pivot. Sorry. Okay, new pivot is here, the red color. The new pivot is here. Okay. So repeat the process, make the pivot cell become 0. Okay, so now this is one more prime. In the table 2, you have R1. Okay, this indicate as R1 double prime. This is R2 double prime. Okay, this is R3 double prime. Indicate this is table 2. Okay, so the pivot cell have to make it become 1. Hence, okay, you need to take the O, okay, or the R3 prime divide 0.5. Mean table 2, it depend on table 1. Table 1 depend on table 0. So R3, so take from here, R3 prime divide by 0.5. Okay, so I select this one, equal to this, divide 0.5, Control Shift Enter. Okay, and then you have to make these two cells become 0. Okay, so we take the row 1. So, okay, row 1 double prime depend on row 1 prime. Okay, mean row 1 at second table depend on row 1 on in first table. So -6, the operation will be add up with 6 times of new pivot row is R3 double prime. Okay, so you have here equal the O, okay, row 1 in table 1, because -6 plus 6 times of new pivot row. Make sure, okay, don't put plus 6. You must 6 times of the new pivot row. Control Shift Enter. Okay. Then it left, okay, row 2. Okay, row 2 depend on the row 2 from first table. Okay. You have positive 0.5, then you minus 0.5 time of the new pivot row, which is R3 double prime. Okay, so the operation, you select this equal to the O, row 2 from table 1. Okay, positive 0.5, so minus 0.5 time of new pivot row. Yeah, Control Shift Enter. So, okay, then now we notice there's no more negative column, okay, in the objective function row. Okay, and when we pivot at column C, C will go in as basics. Okay, S2 become living variable. Okay, S2 is living, and then C, okay, become basics. Okay, or we call C is actually entering variable. C entering become basic variable. Okay, and here, okay, D is actually entering variable become basic. Okay, and then, okay, so when there's no more, okay, negative column, the solution is optimal. Okay, in here. When there's no more negative column in objective function row, the solution is optimal. Is the optimum solution. Then how to read the solution? It will let the basic variable equal to right hand side. So that's why the Z is 140. The D is 7. C is 2. C is 2. Check back if what the graphical approach just now. Right. C2, D7, profit is 140. 27. C2, D7, the profit is 140. So this is solved using simplex method because it's more flexible. You can solve more than 2 decision variable. If using graphical approach, it's limited to 2 decision variables only. So and then I would like to show you also if we use the solver. If we want to use solver, so I'm going to build the decision variable. You build the decision variable, you got D, C, sorry, C here. I cannot put it here. D here, C here. Why? Okay. And then the objective function. So you got 16D, 14C. So the Z. So you put out the objective function. You got actually this 16 times the value of D, 16D plus 14 times the value of C. Initially, we don't fill anything, means D is 0, C is 0. These are our objective function. And then the constraint. Number 1. Constraint number 1 is here 2D plus C equal to 16. So 2D plus C. And then we need one left hand side to key in the formula. This is the right hand side. First constraint 2D plus C equal to 2D plus C less than and equal to 16. This is also less than equal to 9. This is 2D plus 1C. Second constraint is 1D plus 1C. I make everything center. Then the left hand side, you put up the formula. Is actually you have here 2 times the value of D plus 1 multiply the value of C. Then enter. The second constraint is actually you got 1 time of value of D plus 1 time the value of C. So mean the left hand side formula is key in here. Left hand side, right hand side is constant. And then now we are going to use a solver. This is our Office 365. So the solver layout will be a little bit different. Okay, and those who don't have the solver, you can go to File, More, Options, Add In. Okay, and then go check on this solver add-in. Okay, and then you can get the solver from from here. Okay, okay, I got this solver. Okay, so set objective function. I delete it. Okay, we want the objective function z here, this value, to be maximized. So maximize. So we want this cell value is maximum. Okay, by changing the variable cell, changing this value. Initially, we didn't type in anything. Excel will assume they are 0. That's why the z is 0. Initially, D0, C0. Okay, then where's my here? And then subject to the constraint. So we add the constraint. Okay, our constraint. Okay, we have both left-hand side are less than or equal to right-hand side. So I just need to key in one constraint. Okay, select the whole row. Okay, if let's say first constraint is less than, second constraint is greater than, then you have to add in two constraints because both left hand side are less than or equal to right hand side. So I can group together the whole left hand sides. So because here you can change. Okay, and then the constraint here. So I have left hand side less than equal to right hand side, and I add, I cancel. And then select simplex linear programming, click solve. Okay, it gives you directly C is 2, D is 7. Right, C is 2, D is 7 compared to just now. Oh, yeah, you should give this one. Okay, then I can select it. Then compare with just now using simplex. Simplex, we obtain C2, D7, Z is 150. Okay, and then using solver, so it gives you the solution. C2, D7, Z is 140. This is using Excel solver. Okay, don't use this one. This one is a bit difficult. Use this one. Yeah. So set objective, this cell, the Z cell maximum, by vary the cell here, constraint, the left hand side less than or equal to right hand side, solve. Change to simplex linear LP problem. Okay. So in this video, we have covered how to solve the maximization problem with two constraints using graphical approach, and then using simplex method, using solver. So for simplex method, for maximization problem, identify the most negative column. It will be pivot column. Ratio is the right hand side divided by pivot column. The smallest positive ratio, this one, give the pivot row. Intersection of pivot column and pivot row give you the pivot cell. So you identify anti-pivot cell and you can copy it to make a new table. And then in the new table, you need to make the pivot cell become one unit using suitable row operation. Make the cell on top or below a pivot cell become 0 using suitable row operation. Your row operation must be, let's say you are going to make changes on row I. So it's row I plus minus k time of new pivot row. Then put into the new row I. Okay, and then after you make up all the cell below or on top of your pivot cell becomes 0, like here, becomes 0. And then mean this one you make pivot cell become 1, make the cell on top below pivot cell become 0. But then you have to check, is it still contain any negative column in the objective function row? If yes, identify a pivot column, calculate again your ratio. the smallest positive ratio give the private cell. Okay, and then you copy it down to make table 2, and then okay, make again repeat and make private cell become 1 unit. Make the cell on top below private cell become 0 using suitable row operation until there's no more negative column in objective function row. Okay, and when you pivot, in table 1 we pivot at column D will go in as a basics. Okay, and then S1 is leaving, so S1 is leaving variable, D is an entering variable as basic variable. Okay, when we in table 2 we pivot at column C will go in as a basic variable, so initially S2 will become leaving variable. Okay, after no more negative column in objective function, the solution is optimal, and then you read the basic variable equal to right hand side. So Z equal 140, D equals 7, C equal 2. Okay, then this is using a solver. Right, can get the solver. Set your objective function, the Z value, vary the cell C and D here, constraint the left hand side less than right hand side, choose a simplex LP, solve, then make sure here key in the formula 16 times your value of D plus 14 times this value, and then left hand side also formula 2 times D 1 C according to your constraint. Okay, and this one 1 times D 1 times C. Okay, so with this, thank you for your attentions.